Okay, so so there could be some small issues with network connectivity. If in case you can't hear me, or if there are any problems, just let me know, because I'm noticing some issues today. So by the way, can you hear my voice clearly? Can Shiva answer if she is there? Hello,
Yes, sir.
can you guys hear me?
Yes, sir.
Okay. So in case there are any network issues or any voice related issues, just put up on the chat box. Okay.
Yes, sir.
Yeah. So today, yeah. Thank you. So today we'll be starting with the actual data structures part. And as the first example, we'll be doing stacks, and we'll be doing them by using arrays. So stacks and queues are the two basic data structures that we'll be doing before we move on to linked list. And after we do a little bit of linked list, then we'll again implement stacks and queues using linked list instead of arrays. Yeah, so the first we'll just discuss about what stack is as a data structure. So we have heard this word earlier. So for example, the place where we have definitely heard it is program stack, where we put activation records of functions. Either the operating system puts activation records of functions one on top of the other, and then it is removed as the function execution is complete. We'll say that this is program stack consisting of activation records. Okay, this is one example. Typically, if we say we use normal language when we are discussing, so you will typically use the words like stack of books or stack of plates. Stack of plates in the kitchen or stack of books on your table, and we say that there is a stack of books over there, and that needs to be sorted out. So when these words are being used, and so essentially what it is about is we can guess that it is one thing on top of the other thing. Okay, so this seems to be some kind of pattern in which data, which is either activation record or book or plates, are being arranged. So let me ask you the question that if we have this kind of arrangement, which is one on top of the other, what are the important properties or operations that you can think of or that you can perform on such kind of thing? So you have this activation. Let's imagine that you have data arranged in such a fashion that where one data is on the top of the other. Okay, so the top of the other is in some way like we do it in the stack. So what do you think basically would be, and I will call this itself as a data structure, let's say. So in that case, what would be the property of such a data? What will be the properties of such a data structure? Or what could be important considerations that you will have in doing different operations? So you can type out in the chat box. We'll discuss about this. Yeah. So what Onkar says is right. I mean, there are 2-3 answers which came in. So adding another object on top, removing the topmost object. Okay, that is not completely correct. We'll see why that is the case. Object that we first insert can be removed at last position. Okay, that is one observation, important observation, that when you put things on top of the other, typically the thing that you will remove will be the one which is on the top, right? Now, some people might argue that actually that is not the case, and I mean, they will say that you give me a stack of books, and I know that I have to remove some fifth book from the top. What I will do is I will take out the first four books, hold it in one hand, remove the fifth book from using another hand, and then again put back the first four books back again on the stack. But then that is a clumsy operation. I mean, that can be done, but that is a clumsy operation, we would say. So generally that observation is not very efficient, not very easy. So that's why the operation that we have as far as removing the book is concerned, or removing the element is concerned, is the one which is where on the top of the stack that we'll remove first. Okay, whether it is a book or a plate or anything like that. So this is for the removal of the object. Okay. Uh, so that is one thing. Then object that can be inserted first can be removed at last position. Okay, yeah. So the other corollary of that is essentially it means that the one that you put the first time will be removed last. Okay. Uh, Top plate can be accessed first. I mean, only the top plate can be accessed basically, and then if you want to access any plate below that, you have to first remove the top plate, and then only you have to access the second plate, and likewise. And that's what typically at our homes we do basically when we have to wash the plates. That we will typically pick up the one which is at top, and then the second and the third, and likewise. We cannot remove an object until all objects above it are removed. Yeah, that is also another corollary of that. What I was just saying, that to remove some object, basically you have to first remove all the objects from the above. And for that again, we said that only the top plate can be removed first. So you have to start from the top and the second one and the third one, and like that. Basically, you have to keep on doing. We can add something on the top and we can remove said first object. I don't know whether it is meant by the first object. It is essentially the object on the top. So essentially what we are saying over here, that the thing is that whatever we are put in last, so it is called as last in and first out. So whatever you put as the last object, you are putting one on the top of the other. Whatever you are putting as the last remains basically at the top, and that can be removed first. So we can say that this property is what is called as last in first out, and this is in other words it is also called as LIFO. Okay, so this is essentially the property of the stack. Okay, so I will say that if I have the stacks and I have examples, let's say, so these are the two examples, and this is the property. Okay, it is not going. Okay. So the property that we follow is last in first out, where the object which is put in last is taken out first, which also is the corollary of that, as I think Vishaka was saying, is that the first object is taken out last. But it is just saying that last in first out actually implies that. So first object is taken out last. So maybe this could have been called as first in last out, but meaning is essentially the same. So typically it is said as last in first out. Okay. Okay. So this is the second one. Another thing is that only the top element is accessed, is or can be accessed. Now, even if we claim that, okay, I can access the third element by removing first two elements, so we have to remove the first two elements basically, and maybe store it somewhere. And then you have to access the third element, and again put the first two elements back. So essentially, even though you can write such a functionality, but internally you are using the functionality of removing one object at a time. So that's why we can still say that this is still about the accessing only the top element at a time. Okay, fine. So this stack we can implement, as I said, it can be implemented by using either arrays or linked list. So what it means is this. So what are the operations that we require? So I will write down the operations also. Okay, later on we'll discuss it. But before that, so we are saying that what we require is, let's say, a stack of, let's say, integers. Okay, And now what I require is a way to store these different integers. So the simplest way in which I can store definitely is the array. So I can decide that I will store it in array. But now the array has a property that any element can be accessed at any time, right? I mean, you can do any a of I you can access. So you want to restrict that. You don't want to tell the outside world that this can be done. Rather, you have to tell the outside world that this cannot be done. And the only operation that I am suggesting to you is to access only the top element. So you can put the element only at the top, and you can remove the element only from the top. These are the only two operations that I will provide you. So the what is the data structure basically I require? So perhaps I will require data structure. I will say that if I take data structure which is array, and I will say that this array is not enough. I require to know where the top is. So I require an element which is called as top. Okay. So now what are the operations which I can do over here? Before we actually see how those operations can be performed, what do you think could be the operations which are required to be done on stack? I'm asking about the functions, let's say. Yeah, functions or operations, just like we discussed in the case of student database, right? Generally, what operations can be performed over here? So I think insert was said. What else? Delete. But insert is going to be special. Remember that. Okay, because I think someone is saying, I think Pulkit is saying that it is adding another object on top is perhaps a better way to say it. Or let's say this insert is a special insert where you are adding element at the top. Okay, and delete basically doesn't mean that you can delete anything as you did in the database, but this is removing element from the top. Okay, what else? Only these two operations? So insert, or which is adding element at the top, in stack parlance it is called as pop up. It's called as push operation. And delete, which is basically removing element from the top, is called as pop. So pop is delete, remove element from the top, and push is something which is adding element at the top. Okay, what else? I'm surprised. I mean, I was expecting something. Find out element at the top. Okay, so which I will say that print element at the top. Print element at the top. This is possible because top is accessible. Size of stack, yeah, I can ask the question. So essentially size of stack meaning in case of in general we'll say that how many number of elements are present, because size in case of let's say array, size could be defined something else, but how many elements are present at any given point in time. So number of elements in the stack. Okay, so I can say that num elements in the stack. Index of any number, no, that is not allowed. I mean, you should not try to get index of any number, then you are using it as an array. Okay, because in stack, remember that it is like a stack of plates or stack of books. Okay, you are not allowed to access any element below. You are not allowed to go through that. Actually, the only operation you can even actually go down is by removing the element at the top. Unless you remove the element at the top, you can't access actually the second element at all. Okay. Keeping track of topmost element and dust size, checking whether empty or full. Yes. So is stack empty and is stack full. Now is stack empty and is stack full. These are the two operations. Now, so is stack empty meaning whether the stack does not have any single element. Okay, that question can always be asked. But is stack full is kind of a special operation which is available in case of which is required in case of array implementation, but not perhaps in linked list, because the restricted size of memory will come typically in case of arrays. So there we should bother about this function, but this function is typically used, rather defined for array kind of situation. But what else? I mean, you are not telling me the most important function. Yeah, I read the message that my screen is getting lagged little bit. So I hope at least I'm writing slowly. So now whatever you say, I think is stack empty, is stack full is written over there. But other than that, can you tell me? I mean, if you can hear my voice, what is the function which is missing? Yeah, initialize. So create stack. This is the most important function, right? I told you much earlier that the most important function for any kind of database is to initialize. So I will say that the most important function is initialize stack. Okay. So someone has unmuted. Please mute yourself. Okay. So initialize stack is what we have to do in the beginning. So question is, how do we implement this? So answer is simple. Imagine that I have an array, and I will say that I have an array like this. Okay, and I have different array elements which I can just show by having the divisions. So we need not bother about what is contained in over there. So I can just show the divisions over here. An array could be of larger size, whereas at any given point in time, my number of elements in my stack could be much smaller. Okay. So this could be the array, but then at any given point in time, let's say that my top element at or a top index at any given point in time is over here. Okay. Now I will show you that there is little bit of problem with this representation also, in the sense that there is a reason why I'm not showing you the contents, and we'll discuss about it. But imagine that this is the top element. Okay, or this is a top index, I will say, and so I can imagine that starting from this is the index 0. Starting from index 0 up to the top index, basically I have elements in the stack. This is my stack contents at any given point in time, and there is some empty space which is there out there, where I can use the remaining I can include remaining values after this top element. So what I can imagine is essentially what I can do is that I can add an element by saying that I can take my top to the next location and add the element, and when I want to remove the element, I can take my top to the earlier element. So which means that these other locations can be overwritten. So if you can imagine something like this, that if I tell you that in my stack I am inserting, let's say that I am doing the operation push 5, push 7, push 9, pop. Pop always means that you are popping out from the top. Then let's say push 11, push 13, pop, pop, push 15, pop, pop. So can you essentially draw how the contents of this array would move, basically what it would contain at every point in time? Okay, so just do that exercise on in your copy so that you understand. So remember that when I do, so don't bother about this data structure, this array kind of thing right now. You can do it on top of each other also, that is perfectly fine. And I can write 5 at the bottom, and then above that 7, and then above that 9, and when you say pop, you remove 9 from there, and then check what is there basically, and then similarly. So this implementation we'll discuss in a minute. Basically there is some one small very important issue that we need to discuss before we do the array kind of implementation. So right now you can just do an exercise where you do the things just to make yourself acquainted. You can do it in your copy and you can just write down, and then we will discuss what is the final situation when such operations are done, and then we'll come back to this, that how this data structure has to be implemented. So there is a small issue with respect to the top that we have to discuss. Okay. So so just do this. In a minute I will ask you what your contents are. So let's say that now we want to implement this. So what I have is, let's say I have, so I will not write in the I can write in the stack in this array also, but if I don't bother about the top element for the time being. Okay, so the because it may lead to little bit of confusion, but otherwise what I can do is I can say that I can write always one after the other. Okay, just in the not in the array format, but let's say I will just write one after the other, like this. So first I had push 5. So what is this? So when I say you can write one on top of each other, you can easily see that, and we discussed it in the case of, I think, activation record, this program stack also. So this basically thing, this array, you just turn 90 degrees anti-clockwise, you will get elements one on the top of the other, right? I mean the zeroth element or the index 0 will come at the bottom, and then 1 and 2 and like that. So you can imagine that when we are writing in the horizontal fashion, still we can turn it 90 degrees anti-clockwise, and we can get the elements one on top of each other. Or if you want to write on top of each other, that is also perfectly fine. Okay. So if I do 5, 7, and 9, okay. So this is initially when I say push 5, push 7, push 9, and then I do a pop. Whenever I do a pop, imagine that I can print basically that what I have popped out. So there is a screen. On screen, what happens is it prints 9 basically. Okay, but now it removes the 9 also. Okay, and then it has push 11, so it pushes 11, then it pushes 13, and again there is a pop. So with pop, now what gets printed is one which is on the top of the stack, which is 13, so it is 13. And then there is another pop, which means that what gets popped out is 11, and then these two elements are removed. So as 13 is printed, let's say it is removed, as 11 is printed, it is removed, or rather it is removed and then it is printed, and I still have back. Now again I have 5 and 7, I have reached up to this particular point, right? Then I do a push 15, and then I do a pop, which means that I print 15 over here, so 15 is removed. I do another pop, which means that I do a 7. Okay, I remove a 7, and then at the end of it, there is on the stack there is a single element which is 5, which is remaining, and up to this point I have printed 9, 13, 11, 15, 7 on the screen. Okay, and only 5 is remaining now. Okay, so you can see this how this operation takes place, right? Now we have to decide and decide that as we start. Okay, as we start, so the first thing I need to understand that if I want to implement this, so can I implement this operation? Yes. Now, what is the meaning of pop, and what is the meaning of push? Push means basically I go to the next location. Somehow I keep track of the top. Okay, and whenever someone says push something, I go to the next location and write the things over there. Okay, and whenever someone says pop, I know what is there on the top. I essentially I print that element and take my top to the previous element. Now, someone may claim that this element still exists. If I take top to the previous element, let's say that I take top from here to here, someone might claim that in this location where it was earlier, that element is still there. I agree, but remember that next time you do a push, again this will come in over here and you will override the element over here. So as far as all practical purposes, whenever you move top to the left side, all the elements on the right basically are inconsequential or they are irrelevant. I mean, if they even if they are content, they are just junk values, and you are next time you are going to override those elements. That's why they are not bothered. So we are not going to erase them, or you can erase them to some default value if you want. If you know those such default value, if there is no default value, then it need not be done. You can just do this. Now what is the so can I implement a stack by using one array and given a top? The answer is yes, because what I'm going to do is every time someone says push, I'm going to move the top to the right and add an element over there. And so whenever someone says pop, I'm going to remove the element and go one step back. Okay. So maybe the array and the top. And what is top basically? So this is array. Let's say I'm taking a stack of integers. Okay, stack of elements, and elements could be integers. So I have array of elements. So how is the stack formed? Stack is formed by having array of elements, and I have top. So what is top basically? What is the type of top? What is the data type of top? Yeah, it's integer. So essentially top is an integer. And now if you have noticed, essentially these two things, array of elements and top, which is an integer by the way, so it doesn't depend on whether I'm taking array of stack of integers or stack of floats. Even if you take stack of floats or stack of student records, this top is still going to be integer because it's the index, right? This point has to be understood. And now if you see these two things together, they form a unit. They form basically these two things together. I can declare them this together, whatever it basically comes up, I can declare that as a stack. Okay. I have an option. What I can do is I can have array separately. I can say int. Let's say it's a stack of integers. I can say int stack size 100, and then int top. And then these two things together, I will say that they are arrays, and these are two different declarations. But what is a better way basically for declaring stack now? It's a structure because it's a unit. Remember that the the structure essentially captures one single unit where elements which are related to each other are kept together. So I can say that if I want to declare a stack, what I will say, and I'm going to modify this by the way in a minute. Okay, but so you can write down right now. So I have let's say I will say that it is struct. I will say stack tag. Okay, and what it contains, let's say I want array of integers, then I'm going to change that as well. But right now let's say I want array of integers, then I will say I have int. So what I require top and array of elements, right? So first let's say I require top. Okay, and then I require array of integers. So array of integers can be taken as int elements, and let's say this is stack size. I need to define what stack size is, or I will say max stack. Okay, so max stack means that it is the size of the maximum size of the stack. Okay, so these are the two okay, these are the two fields of this struct stack tag. Okay, and I can define the things like this. Okay, now I can do this definitely, but remember now what happens is that I require a stack, some stack of integers. What I have to do is I have to declare struct stack tag and its name, basically name of the variable, which is essentially, let's say that I will say something like my stack. So what it means is my stack now is a structure which contains top as well as array of integers of this max stack size, right? And then perhaps I can keep on using this top and elements both by doing max my stack dot top equal to my stack dot top plus 1 to increment that. And similarly, to access the elements over here, I can say elements of my stack dot top, basically, which is the top element, and then I can update it. Okay. Here the user still knows that but is this stack tag type, is this stack type, basically if I say stack tag, so is this a type? Yeah, it is a struct stack tag is a type. Okay, but the question is that can I do little bit better? Can I do something like stack my stack, and this looks much better, right? I mean, this directly tells me that stack is a data type and my stack is a variable of this type. So question is, can I do this kind of declaration? I will love it, whether it means that I have my own type defined stack. I need not tell you what it is basically. Of course, it has to be told to the compiler, but I need not. I can just use this as a programmer, and I just love this. Other than using this struct always. Now there is a way out in C language, which we didn't take earlier. This is the first time I am introducing this, which is called as type def. And type def basically is a keyword which is used to give another name to the existing type. Okay, so for example, I can say that type def, I can say int. Okay, and I can say that type def int is of type item type. Okay, what this means is that, or let's say item type, I will write like this. So what this means is that there is another name for integer int, which is basically item type. And if I do this, at least this part, not the first one, but this one, I can change it to item type. Okay. Now, is this like hash define? It is not. I mean, you may say that it is kind of replacing this int with item type with integer. Actually, it is integer. Wherever item type appears, you write integer. You can say that it looks like hash, but it is not hash define in the sense that it is not being done by the preprocessor like that. It is like just understood by the compiler that there is another name for the data type integer, which we are providing with the new name, which is called as item type. So this is the existing name. So typically the structure of type def goes as type def existing type and type name and new type name. It's not new name actually new name. Okay, so I can say that this this is the way in which it gets done. Okay, so what I'm doing over here is that I just replace this. Now it looks much fine, that because now I'm not telling you. If you just look at this, by the way, shall I replace this int top with int also with item type? The answer is no, because remember that irrespective of whatever the array is of, the top is always an index basically. Okay, so it has to be told to be an integer. Now, even if you may say that this is item type is also an integer, but that is not what the meaning conveys. Essentially, here I want to say that this elements is an array of items. Okay, and this item type, tomorrow I can define this int as a float also. But even if I declare this int as a float, this item type as float basically, so it's similar. Suddenly, these elements will become of floats. But that doesn't mean that this top should become float, because top is not a float. Top is always an integer. And that's why basically this top has to be kept as integer, whereas this elements array can be of item type. So this is the first thing. So with this, basically we understand this type def can be used like this. Now, if I can use this type def, so what does type def says? Type def existing type name and new type name. So perhaps after this gets done, what I can actually do is I can say that type def, what is the existing type name? It is struct stack tag. Okay, and new type name could be stack. Okay, so I can say that type def struct stack tag. So this is the existing, existing type, and this is a new type that I'm providing. And after that, I can do stack my stack, which means that this is a variable I'm defining over here. Now, so these two things can be written separately. First, you define what struct stack tag is, and then you do type def struct stack tag is nothing but stack. Sometimes we can actually combine these two things together. So what I can do is I can say type def, and then this is the existing type. Okay, this I can say is the kind of existing type, and after that, basically I can give the name which is called as stack. So you have to understand that this is like saying that this is the existing name and this is the new name. This is different than, remember, this is different than if I do this, the meaning is different. It means that stack is a variable of type struct stack tag. But if I not do this, and if I do type def struct stack tag and then stack, it means that stack is another name for this existing type, which is this, which is struct stack tag, which has int top and which has item type elements. This is the existing type to which I am giving a different name, which is called as stack. So in this case, stack is not a variable. In this case, stack is a type name. Whereas if I don't have the type def over here, then stack becomes a variable of struct stack tag. So this differentiation has to be understood very clearly. Okay. So now if I put type def over here, essentially what I'm doing is I'm declaring stack as a type. So then I don't require this. This is what, so two things I have done together. I could have done them separately, but I could do the two things together. Okay. So this is the use of type def. Okay. And now this is a beautiful feature. I would say it's one of the most beautiful features that C language has provided, because now it allows me to declare my own type. It looks like a type now. I'm not telling you that it's a struct or something like that. It is a struct, of course. But then when I do this declaration, it looks beautiful that, okay, I'm taking a variable of name my stack, and the type of this variable is stack. So essentially I'm taking a stack. Okay. So I'm defining, actually now I'm defining a user defined type. I'm actually having a user defined type, which looks like a user defined type. Okay. So this is a very, very important feature for us, and this is going to be our bread and butter. I mean, in the sense that we are going to use very heavily from this point onwards, we are going to use type defs only. Okay, we are not going to use this. We are going to use this struct only for declaration of type def. But after that, we are just working with. We are going to work with only with the type defs. Okay, with these new names which have been declared. And now I can imagine. Okay, as we are moving to the end, now I can imagine that. Rather, let me write it over here itself. That now I can imagine where did I write the operations. So now I will say that these operations, let me say that let me just copy the things again. Okay, over here. Okay, and let me say over here that the operations that I want. Okay, did it go to the next page? It didn't. So yeah, so I think this came unnecessarily. Okay. So now these operations, I can say that these operations on the data type, I can say stack is what I want to. Now this stack and this stack are the same. Okay. So this is what, if you want to know that these two are same, let me highlight them. So I'm saying that the operations on the data type stack that I have defined, on this stack, I want these operations: initialize stack, push pop, print element at the top, size of the stack, is stack empty, is stack full. Is stack empty tells me whether the stack is empty. And is stack full tells me whether stack is full. Okay, fine. So now I want to define all these operations. The first operation that I want to define is initialize stack. Okay. So now let me get into the program mode. So let me just do a few things, and by that time I will just ask you one question. You may answer it. We have 5 minutes remaining. That is okay. The question is that the first function that I have to write first, which is initialize stack. So what should initialize stack contain? Okay. And when I write it in the program format, it will become more clear. But for the time being, let me just tie up the loose ends. So one loose end that I need to define max stack. So which I can define, let's say 100. I don't know whether you guys have realized that this type def provides a very, very powerful way of programming. Because today you are wanting to have stack of integers, you are defining item type to be integer. Tomorrow, if you want to have stack of floats, only change you have to do is you have to just change this into float and everything else would remain the same. Okay, that is the beauty of it, because every place, at every other place, we are going to use this atom type. Okay, so only thing which changes is basically over here, and you will buy in free, by free you will get, if you have stack of integers, you will get implementation of stack of floats also just for free. You just have to just make one small change over here. Just like in case of hash define, you could have changed 100 to 500 and you get a bigger stack. Similarly, a different type of stack you can get just by changing this. It could be student record also. Okay, later on you will see that this will be anything over here. Okay, so all these things are possible. So this is the first loose end that I have. And there is another thing that I require. I don't know whether I should tell you, but maybe I can right now. Is that we are going to these push pop operations. We are going to require the status of whether those operations are successful or failure. And we required that in the case of student database. So believe me that we are going to require it even in this case, because you can imagine. Can you imagine when push can be failure or where pop can be failure, for example? You can first answer this question. Where do you think that push will be failure in this implementation? That I cannot push newer element onto the stack. And when will it be the case that pop will be failure? So yes, so when stack is full, meaning that array is full, rather I cannot do push. Similarly, when array is full, array is empty, I cannot do the pop, which means that the outside world needs to know that it called push or pop function whether the operation was successful or not. So we require this status code. Remember status code in the case of student records we had taken. We require status code as failure and success. And there we had taken them as integers. 0 is failure and 1 is success, something like that we had taken. But now that we have done the enums, I can define basically enum. I can define enum and I can say failure is 0 and success is 1. And I can define this as a status code. Better still, what I can do is, so what this does is status code is a variable of type enum. But what I can do better than this is that I can define status code as type itself by doing type def. So it says that enum failure success is the existing type, and that type has got a new name which is called as status code. So whenever I require a status code, I can just say status code SC, which means that SC is, let's say, variable name of status code. I can status code SC type enum having two values, failure and success. So it becomes, again, the coding becomes beautiful. I can use status code as just as a type basically. Whenever I want to return that or anything, I can just say that it is returning back status code. And now at this point, now we have done this, tied up the loose ends. Let me ask you one question and we'll stop at that question. I will not answer that question. What should my initialize stack now contain? Okay. So for that, perhaps I need to show you my main function. So let's say that I have a main function where I'm declaring my stack, my stack variable. So let's say that I have main function over here. And the first thing I did in the main function is that I defined a variable of stack of type stack. So I said that there is a stack and the name of my stack is my stack. Okay. So this is what I have done. And now I have to initialize this my stack. So how do I initialize? So perhaps I need to write a function, but what should this initialize stack function is what I need to write. What should it take as input basically? And what should this initialize function do? These are the two questions that I'm asking. There is a 1 minute remaining. Either you can answer on chat box. I'm not answering that question. And you can think basically what it should contain. Now we'll discuss about what the parameter would be, but you can imagine that this initialize stack would contain what? Setting the value of top. Great. So you have to set the value of top in the initialize stack function. You have to say that it is reset, in the sense that stack is basically at the starting point. Now I want to ask a question and I will leave you with that question. Yeah, now good that Onkar is basically claiming that top should be -1 and size should be 0. There is nothing like size over here with me right now. So it's okay. But Onkar is saying that top should be -1. Okay. My claim is that yes, top could be -1 or top could be 0 also. Okay. It's a choice. Either you can have top by default. Basically, if you ask me, that I tend to put top equal to 0 most of the times. So maybe I can put top equal to 0 or I can put top equal to -1. And that's a choice that I have to make, that we have to understand. The question that I'm leaving you with today is that what are the implications of this choice? What happens if I take top equal to -1 as initialization And what happens if I take top equal to 0? What are the implications of this decision? And it's a very, very important decision, believe me. So are there any implications of this decision? And if there are any implications of decision, what those implications are? This is the question I'm asking. Is the question clear? What are the implications of setting value of top to -1 or setting top equal to 0? Someone is saying top equal to -1 makes implementation easier than using top equal to. I don't know whether it is easier or difficult. So I'm asking you, what are the implications of this? And if you think it is easier, why it is easier? I don't think so that it is easier. Okay, nothing is perhaps both are equivalent, but it has very important implications on the implementation of the whole thing. I want you to realize that. Okay, so I'm leaving you with this question. Some people are answering. You can answer on the chat box, but I'm stopping this discussion now, and we'll start from this point onwards tomorrow. Okay. So you can put on the things on the chat box. That is fine, and we can leave the meeting now, and we can take from this point onwards tomorrow. Okay. Yeah. Thank you.